All right, for 17b, we have a similar situation, but now we're looking at the angles. So we want to maximize this angle. I called it gamma, um, the angle between, and that one's a little challenging to me, so I thought, well, I know a little more about alpha and beta here because they're part of these right triangles. And so that's what I figured, because these are connected, right, they make alpha, beta, and gamma together make a straight angle, 180 degrees. So if I can minimize these, then surely I can maximize gamma. And so the important thing to see here is that if I call this x again and call this 20 minus x, well then I know that the tangent inverse of opposite over adjacent, 5 over x, plus the tangent inverse of 10 over 20 minus x, that should equal alpha plus beta. So those are my two angles. So if I can get those two angles together, I don't know, I'll call them S or something. If I can get those two angles together to be minimized, then I've automatically maximized that. And so I can take the derivative. So if I take the derivative of S here, the thing to remember is that the derivative of tangent inverse of x is 1 over 1 plus x squared. And so in this case, I'll just kind of do it for this, and then you'll see the rest. And the algebra works out similarly. You go through the same process we did in the last video, where you move one to one side, one to the other side, multiply by the denominators, just like we did in 17a, multiply by the denominators, and then kind of do your algebra from there. Different result, I think, but same sort of situation. So in this case, if I take the tangent inverse of that, I get 1 over 1 plus this squared, and then the chain rule tells me that I have to take the derivative of this here. This is, we could rewrite that as 5 to the x minus 1. I like to do that because then I can see, oh, okay, I take my derivative here, I take the negative 1 down, then I have the 5, and then I have the x, and I subtract 1 off, so now I'm at 2. So now I have negative 5 x to the negative 2. Okay, so now looking at this here, if I go ahead and multiply that out, so I'm going to just put my negative 2 up here like that. So I have 1 plus 25 over x squared. So I have that. What I'm going to do is go ahead and make this a common denominator here. So if 1 is the same as x squared over x squared, right? Anything over itself. So I'm going to change that to all being over x squared. And so now I have x squared plus 25. But this actually simplifies because this is the denominator of a compound fraction here. So this is actually, I can move up here. So now I have negative 5, x to the negative 2, x to the positive 2, x squared plus 25. Well, these two x's undo each other, right? If I made this one base of x, then I'd have negative 2 plus 2, which is 0, so x to the 0 would be 1. So I just have negative 5 here, and x squared plus 25 here. So that gives me the first half of it. I do the same kind of steps for the tangent inverse of 10 over 20 minus x. It's a little more complicated, but it's the same general idea. For that piece, I'm going to end up with 10 over x squared minus 40x plus 500. We've seen that before. So I get those pieces, right? And then I'm basically going to now, since it's this plus this equals 0, if I have this equals now positive 5 x squared plus 25. Okay. Now I'm solving for this, and I can do my multiplication through and solve. So maybe we'll just go one more step just to make sure we're getting the process here. So I kind of shortcutted us on this, but you should be able to get to that point. So now I know that I have 10 times x squared plus 25, so 250 equals 5 times all this. So 5x squared minus 200x plus 2500. That makes sense, and then I can start simplifying. If I move this over, now that gives me 5x squared. I don't have any x's here, so that's just going to be plus 200x, and then I'm going to subtract the 2500, so whatever that is, negative 2250 equals 0. Clearly I can divide by 5, so that's, let's see, 240x, and if I divide by 5 here, I have 450, I think, minus 450. Okay, and from there it's quadratic. I'm not even going to go through the effort of solving that because that's just algebra. So that should give you a good idea. And so if I've maximized that, so I found my point there. That's my minimum point. You see that that's the parabola. And then I find my point, and that's that. If that minimizes these, it must maximize the gamma. All right, on to the next.